It's a week long. It's not in person.
28.
Okay. Excuse me. All right, good morning, everybody. Welcome back from reading week. I hope your reading week was better than mine. I got a cold over reading week. So before reading week, we were talking about implementing classes. At this point in the course, you should know how to create a simple class that is more or less functional at this point in time. So you can make a class, you can add fields, you can add some simple constructors, and you can add some simple methods. The rest of the course is basically dedicated to making classes, and in particular, how to make them correctly and use them to solve some hopefully interesting programming problems. So to start with today, we're going to talk about documentation, because we haven't really talked about documentation yet in the course. When you document your code, documenting code is not a new idea. People have been doing it for as long as they've been programming. Java is probably the first major language, though, that made the decision that we should embed documentation in the code. And if you want a separate document that describes the code, you should be able to extract the documents from your code and create a document using those comments. And so the tool that does that in Java is this thing called Javadoc. And the comments that you see in your assignments, so the big blocks of comments in front of all your methods and classes, those are all written in Javadoc. So the way Javadoc works, it's a separate program. So it reads your source code and it extracts information from your source code. So the information is embedded in what are called doc comments. So doc comments are these comments that are in front of a class or a field, a constructor, or a method. Sorry, I'm getting some feedback here. Hang on. All right. So the doc comments they're just literally comments. So they're marked with a special syntax. So they use the multi-line comment, but it's /** instead of just /* to open up the comment. The end of the comment is marked with a //. The comment itself is written in plain English. You can also use HTML if you know what HTML is. If you don't, it doesn't matter. There's not an HTML course, so you don't have to worry about it. So the rest of the comment is just written in plain English. When you go to comment a thing in Java, you give it a description, right? And so the first sentence of the description, Javadoc will copy that out and plunk it into the summary section of the relevant part of the document, of the documentation document. The rest of the code will go into, the rest of the comment will go into the extended part of the document, of the documentation document, or the details section. If you want paragraphs in your comments, you can separate separate paragraphs using this P inside of angled brackets. That's the HTML tag for paragraph. And then there are these things called block tags that describe various things that the Javadoc is aware of. So you can describe parameters, you can describe the return values, and you can describe whatever exceptions are thrown. There's many others that we don't talk about in this course. All right, so so instead of following the slides, I'm just going to do this in Eclipse. So there's quite a lot of slides. So if you want to read the slides, you can. Everything I'm about to show you will be described. I'm just going to show it to you in Eclipse to show you how to do it. So this is assignment 3, or part of assignment 3. This is the second part of assignment 3. Second part of assignment 3 asks you to implement a simple class and then document it using Javadoc. The first part of assignment 3 has you implement a class, but notice that the Javadoc comments are already here for you. So that thing right there is a great big Javadoc comment, right, that describes the purpose of the class called interval. All right, so in front of your class, there should be a comment that describes the purpose of the class, right? What does this class represent? What is it used for? When you're commenting something, you want to describe what is publicly available for the feature, right? So you want to tell people what can users see, or what can they do with this bounding box class, right? You don't want to tell them how does this class actually work. So you don't want to describe the implementation details of the class, right? So you don't want to tell people, for example, there are these fields called X and Y, or this particular class uses this very specific algorithm to do X, Y, and Z, right? So you want to avoid that level of detail, right? You want to describe what does the class do, not how does the class do what it does. All right, so you guys don't know well, you may not know what a bounding box is. However, I did give you the generated Javadoc document for the class, right? And so the documentation for the class says that a bounding box is a rectangular bounding box having integer limits. The coordinates of the edges of the bounding box are always representable using an int. A bounding box is just a rectangle, right? And this particular class is trying to tell you that the rectangle always, the corners of the rectangle always fit inside the range of int. It also tells you what direction the rectangle is oriented in. So it tells you that the positive x-axis points from left to right, and the positive y-axis points down, right? So from top to bottom. And it also tells you that points on the perimeter of the box are considered to be inside the box, right? Nowhere in here does it tell you that the bounding box is represented by two corners or by a width and a height or anything else, right? It just tells you what is this thing. Right? And so to generate or to put this information into your Javadoc, I'm just going to copy it because I don't want to type it all in. You would do something like the following. So comment starts with /**. Right? Enter. Notice that Eclipse will stick in an author tag for you automatically. I'm just going to get rid of it. It's not important for us right now. I'm just going to paste in the text, and then I'm going to go fix it manually. Actually, I'm going to not fix it manually. I'm going to do that. All right. And so there's the text that I just copied in from the, yes, question?
Just so to be clear.
Yeah.
From high to low, y gets bigger. So with -1, for example, as you get lower, the number gets bigger, or is it the other way around?
Yeah, so the going down, the number gets higher. So the y coordinate goes.
So -3, -2, -1.
That's right. Yeah.
And
Say, yeah, sorry.
how did you quickly clean that?
Oh, Shift Control F in Eclipse. So if you go into the source, source? Yes, source. There is a format. So format will format your entire code file. It doesn't just fix the commenting; it fixes all the spacing, and it fixes many of the spacing issues. Fixes your indentation and all other things. Okay, so separate paragraphs should be separated by a p tag, so the HTML paragraph tag. If you don't put it in, when you run the Javadoc tool, it's going to ignore the, it's going to render this all as a single paragraph. If you look very closely at the, whoops, right here. If you look very closely at the document that was generated, you'll notice that int is in a different font. And so what's normally done in a Javadoc document is that keywords, so words that are known to the Java language, like types, so int, for example, or the names of parameters or the names of methods, normally those are set in a different font to make them distinguish them from the English text in the comment. So you don't have to do this in this course. I'm going to show you how to do it though. So it's not required for the assignment, but if you want to add formatting, you can. So in newer versions of Javadoc, the easiest way is to do it like this. Right? You can also write straight HTML if you know how to write HTML, but it's easier to do this. And so wrapping up the int inside braces with an @code tag tells Javadoc to format the int using a monospaced font. So it looks like, it doesn't look like a proportional spaced font, so it looks like computer code. There you go. Okay, so that completes the, there's an example of a class Javadoc comment. right? And if you look in the standard library, you'll see that the Javadoc comments are typically, for a class, are typically quite long. And so they go into a lot of explanation as to what the class is used for and how users might be able to use the class. All right, so that's the comment for the class. Now, in the assignment, you have to implement a bunch of constructors and methods. The fields are already given to you. So let's just take a quick look at one of the constructors. All right, so we have a no argument constructor right there, public bbox2. So I'm going to insert that into the class. I'm not going to implement it, but I'll insert it into the class. All right, and so for every public feature that's in your class, it's normally a good idea to add a Javadoc comment for that feature. Right? Our constructor here is public. Right? We should comment that, we should describe what is that feature. Right? You want to describe that because users of your class, they can see all the public features of your class. So they need to know, or they should know, it'd be nice if they knew, exactly what these features are for. So we have a public constructor, we should add a Javadoc comment for this constructor. Right? So /*, whoops, sorry. Right? And then add your comment. So this says that the no argument constructor initializes the bounding box so its left, right, top, and bottom coordinates are equal to 0. So it makes a rectangle whose both coordinates are at 0, 0. So it's a rectangle whose width and height are both 0. Right, I'm just going to paste that in again and then format it. Right, and away you go. So for the class and for the constructor with no arguments, it's pretty easy to write the comment, right? It's just a description of what the thing does. As soon as your feature has, so if you have a constructor or method that has parameters or a return value, then you also want to describe what are the parameters and return value. Okay, and so we have another constructor. I'm probably doing too much of the assignment for you, but anyway, whatever. Right, we have another constructor that initializes the bounding box so that its left edge has that coordinate, right? Its right edge has that coordinate, its top edge has that y coordinate, and its bottom edge has that coordinate. Right? Notice that we have some parameters here. So we should describe what each one of these parameters are. If you go back to the Javadoc comment for the class, right, it tells you it does this. So we can just copy this out. /*. Notice that when you insert the Javadoc comment for you, if you're in Eclipse, Eclipse knows that you're trying to write a Javadoc comment for, Eclipse knows you're trying to write a Javadoc comment. So it automatically inserts the standard tags for you. Right? So it knows that you're trying to document this constructor, and the constructor has 4 parameters. So it automatically inserts the tags for each one of the parameters for you, which is nice. Oops, Control V, okay. If you're using some other editor, you'll either have to figure out how that editor, you'll have to either do it manually or you'll have to learn how your editor deals with Javadoc. Okay, so for each one of the comments, for each one of the parameters, you should describe very briefly what is the purpose of this parameter. Right? Now, a lot of the time it's going to seem like this is not useful because it seems pretty obvious in this case that x left is the x coordinate of the left edge of the rectangle. Right? But in professionally written Javadoc, this will be fully commented. Right? And so if you look at the document here, right, it actually tells you it's the left edge. Right? Notice that Javadoc inserts a hyphen here for you. Right? So this isn't, you don't put the hyphen in your comment. Right? So there's no separator here. I'm not going to insert a separator after x left. Right? The tool will pick the separator that it wants to use to generate when it generates the document for you. Right? And so for every parameter, you're going to describe what the parameter is used for. So this is going to be the y coordinate, the top edge, and the y coordinate. Like that. Okay, so not too hard. So The only things to remember here are the tag is @param, right? It's followed by the name of the parameter, right? And then it's followed by a usually short description of what the parameter is used for. The parameter name here has to match this. If it doesn't, when you run the Javadoc tool, it'll complain. Speaking of which, how do you run the Javadoc tool? All right, so you also don't have to do this in this course. So I'm never going to ask you to generate the Javadoc for a class and submit your Javadoc, because it actually produces quite a lot of HTML. But if you want to check if you're doing your work correctly, it's easy to do in Eclipse. You just go to Project. You go to Generate Javadoc. Right? You pick the project for which you want to generate the Javadoc for. Right, so this is A3, and then you pick the classes or classes for which you want to generate the Javadoc. I only want to generate the Javadoc for bounding box 2. You tell it where should it put the Javadoc, where should it put the generated documentation. So I'm going to put this in somewhere more sensible. So I'm going to put this in 2025, 124. I guess I have to make a new folder. And I'm going to make another folder, A3. And then I'm going to make yet another folder called doc. Again, you don't have to do this. You can put this wherever you want, right? I just want to keep things organized. OK, so you tell it where you want to put the documentation. So that's it right there. You go next. Oh, wait, you can fill in some other stuff too if you want to. Most of these options here are not relevant for our purposes. You can give your document a title if you want. So this would be A3, for example. And then you get to next. OK, here's where you get to put in your options for the Javadoc tool. If you want to know what options you can use, you just go look up the Javadoc tool and find out what options it has. We don't need any for this particular case. You just click Finish. It'll ask you, do you want to move the Javadoc location for A3 for this to the particular folder? You just say yes. Right? It'll chug. Down here, it'll generate some output. If you see any red down here, you want to read what the issue is, because it probably indicates that an error has occurred when Javadoc when the Javadoc processed your document. After you've generated your document, you can go and look at it. So it'll be, you can click the index.html. That's probably the easiest way to get to it. And there's your class, and there's your Javadoc. Right? And if you look at it, if you compare it to the original document, you'll see that it matches the original document. Right? Looks exact same. Depending on your version of Javadoc and your version of Java, your document might look a little different. So every version of Java changes the formatting a little bit. But it's always superficial. So here. So if you look at the comment if you look at the summary section for the constructors, you'll see it's only the first sentence that makes it into the summary section. Right? Notice that the parameters aren't described in the summary section. If you want the details, you got to go down to the detail section. Right? And when you look at the detail section, that's where everything shows up here. All right, so a couple more examples, because we need to know how to document return types and exceptions. I don't remember, is there one that throws an exception? Oh wait, this one throws this one should throw an exception. Yes, here. Okay, so we're not quite done with the second constructor. So the second constructor has some exceptions that are thrown. The way that this class works, it keeps track of the left and right coordinates, the coordinates of the left and right edges, and the coordinates of the top and bottom coordinates. Right? So it's important that the left coordinate be less than the right coordinate, and it's important that the top coordinate be less than the bottom coordinate. Right? If it's not the case, that's an error, right? You can't make a bounding box with these coordinates, so it throws an exception. To document an exception, it's just the @throws tag. Okay. So after your parameters, you describe whatever exceptions are thrown. So @throws. For the exceptions, you always say what is the exception type that's thrown. So it's illegal argument exception in this case. Sorry. Again, there's no symbol in here. The Javadoc will insert a symbol for you. And then you tell people under which conditions is this exception thrown. So our document says it's thrown if x left is greater than x right. So if x left is greater than x right. Again, you can format this using an @code parameter, an @code tag if you like as well. So I'll just do that again. Right, and the reason you would consider doing this is because x left and x right are both names of parameters, right? And so you want to make them stand out a little bit more compared to just the plain English text. Right? It also throws an exception under one other case, so we can just copy that comment, stick it in here, and change the condition under which it's thrown. So if x top is greater than x bottom, an exception is also thrown. Right? Save that, regenerate your Javadoc. So project, generate Javadoc. Once you've done it once, you can normally just hit finish, and it should work. Go back to our generated document, and there they are. Right. In newer versions of Javadoc, a link will be automatically generated for you to the standard, if your document refers to any of the standard library classes. Right. So a legal argument exception is one of the standard library classes. So Javadoc inserts a link to that class so that you can, so that users can simply click on the link and figure out what kind of and read about the details of a illegal argument exception. All right, any questions so far? This is pretty, yeah, question. Yes, it should be. Thank you. Like that. Any other questions? It's pretty straightforward. It's pretty straightforward to do. I guess in this era, there's probably AI tools that'll fill in most of this for you. So I suspect things like CodePilot or ChatGPT may in fact be able to generate most of this documentation for you. I haven't actually tried it. Oh, methods. So there's one other tag that you need to know about. So if a method returns a value, you should describe what is the return value for the method. So if we go back to our class again, we need to find a method. So left returns the x coordinate of the left edge of the bounding box. So let's just stick in that method there. So public int left. Okay, so notice that Eclipse also knows that this is a method that you're documenting and it has a return type. So it sticks in the @return parameter, the @return tag for you automatically. Notice that Javadoc is a little bit inconsistent, right? Here, they use throws with an S to document an exception. For return, it's just return. It's not returns with an S. Why they did this, I don't know. Whoever designed the tool probably wasn't paying attention. But anyway, so return returns the x coordinate. Sorry. X coordinate of the left edge of this bounding box. Or something like that. Right, and of course you should put the description in here. All right, so if you stick in another method and you forget the Javadoc for it, and you generate the Javadoc, oh, sorry, wrong. Finish. You should, yes, you do. So you may have seen it fly by. There it is right there. Right? If you get any thing in red, and again, depending on which version of Eclipse you're using, the warning is going to look different. The tool will warn you about things that are missing or things that are incorrect. Right? So here it says there's no comment for this public method, right? And you asked me to generate the documentation for all the public methods. Right? So it's trying to tell you that you're missing the comment there. Similarly, if you change the name, so I'm just going to call this L. Right? Incidentally, you should never name a variable L in your program. Right? It looks like 1. And so remember, never make a variable called L, lowercase l in your program. If your tag names mismatch, if your parameter names are mismatched, you'll also get a warning. I think it's an error actually. So right there, warning, boop, here it is, right? So here it says error, param name not found, right? So it's telling you that L is not a parameter for your method, right? Needs to be called xleft here. And that's Javadoc in a nutshell, right? So you may not want to hear this, but a pretty important part of a professional developer's job is writing documentation. In fact, your job can only be writing documentation should you choose to take such a job. So there are people who are paid who their only job is to write documentation. If you plan on writing Java code professionally, at some point you do need to know how to write professional quality Javadoc, right? Especially if you're going out for a job interview. So if you're planning on doing an internship, and the company you're doing an internship with is a Java shop, it's pretty important that you actually understand how to write Javadoc comments. Right? So that link right there takes you to the, I think it takes you to Oracle's documentation for how to write proper Javadoc. Yeah?
Is it always the documentation, the Javadoc documentation comes before the method?
Yes, yeah. In Javadoc, the convention is to put it before the method. And the tool is expecting it to come before the method and before the feature that you're documenting. Yeah?
Sometimes I'll see, instead of at code,
Yeah.
in the comments, sometimes I'll see backticks, like markdown syntax. Is that like...
I don't think Javadoc understands Markdown. It does understand HTML. So you could use TT and /TT.
That's how it's written in the first assignment. So
Sorry?
that's how it's written in the first
Yeah, it's possible that's how it's written in the first assignment. It just depends on when the assignment was written and how I decided to format the code. Yeah. All right, so that's Javadoc in a nutshell. Everything I told you in class that is what I would ask or expect you to be able to do on a test, for example. Right? So it's not unusual to see a test question where it's one method or one constructor, and you're asked to fill in the Javadoc for the feature. Okay, moving on. Preconditions, postconditions, and class invariants. So when you're writing a method or a constructor, it's often the case that the method or constructor will have parameters, and there will be conditions on those parameters. Right? So for example, if you wanted to take a point and divide its coordinates by some scalar value s, right, it's probably pretty important that the scalar value s is not equal to 0, because then you're going to end up with infinity and infinity. Right? Because division by 0, results in either infinity or something else. If you try to take 0 divided by 0 in Java, you get not a number. Okay, so divide would be an example of a method that has what's called a precondition. Right? There's some condition on the inputs to the method. Right? So a precondition it's a condition, so something that's true or false, right, that the caller of the method must ensure is true before they call the method. Right? So anybody calling divide has to make sure that s is not 0. Because if s is 0, there's no way for divide to actually do what it says the method will do. There's something important about preconditions. Right? So the responsibility for meeting the precondition lies with the caller of the method. Right? So in this course, you mostly play the role of the person who is implementing the method, right? Or the class or the constructor. You have to remember that your code is going to be used by someone else, perhaps yourself, right? And so the caller of the method, so there's two roles, right? There's whoever's using the code and there's whoever's writing the code. The person that's responsible for meeting a method precondition is the person that's using the code. It's not the person who's writing the code. Right? So it's the caller of the method that must ensure that the precondition is satisfied before they try to call the method. Right? If they call the method without satisfying the preconditions, then the method can do whatever it wants to do. Right? It might run, it might crash, right? It might run and lead to incorrect results, right? Anything could happen. Okay, so if your method has a precondition, then you should probably document that in your Javadoc, right? So Javadoc doesn't have a dedicated tag for preconditions. Instead, what's normally done in Java is that preconditions are tested and exceptions are thrown if the precondition is not satisfied. That's not always the case, but that's often the case. Right. So, so one way to do this is to simply tell people, hey, make sure s is not 0. So for example, here's divide. Right. So divide's in the point2 class. Right? Dividing a point by s simply takes the x and y coordinates and divides them by s. So if you read the documentation for this class, it tells you somewhere, here it tells you in the parameter tag, right? S is the scalar value to divide this point by, it must not be equal to 0, right? And so there's your documentation for the precondition in this method. Okay, so because the responsibility for meeting the precondition lies with the caller of the method, right? So the user, the implementer is allowed to do whatever they want. So they can ignore the fact that the precondition exists, right? In other words, they can assume s is never 0 if they want to. Right? So here, in our first implementation, we're simply going to ignore the fact that s might be 0 and go ahead and implement the method, which is easy. Right? If I want to divide the x coordinate by s, I just divide the x coordinate by s. Right? So this x equals this x divided by s. Right? You can write this in a bunch of different ways. I'm just writing it out this way to be explicit. Right? And this would be a perfectly acceptable implementation of divide. Right? Okay, now the problem with doing it that way is that the problem with assuming that a precondition is always true is that your method's going to run even when the inputs to the method are invalid. Right? And that has some consequences. Right? So if your method returns a value, you might end up returning the wrong value. Right? The method might encounter some kind of error, including throwing an exception that is unexpected. Right? So normally your class should document what exceptions, your method should document what exceptions are thrown. Right? If you simply ignore the preconditions and assume that they're all true, then your method might throw an exception that's not documented. Right? Your method may not be able to do everything it says it does. Right? So your method has a comment on it that says what exactly it is the method will do. You can view that as a contract that the method, so the method is promising it's going to do something. Right? If it runs with invalid inputs, it probably can't satisfy that contract. Right? And if you're working with objects, then your method might end up putting your object into an invalid state. So for the point2 class, if you divide by 0, you could end up with a point whose coordinates are infinity, negative infinity, or this other quantity called not a number. Right? So for example here, in our current implementation of divide, right, if I take a point 1, 2, divide it by 0, I get infinity and infinity. Right? This may or may not be a problem. Right? It depends on exactly how you decided to implement your point2 class. Right? You might, as the implementer of point2, you might say that this is perfectly acceptable. Right? You can have points whose coordinates are infinity. All right. If your method does have a precondition, though, and your method is public, the normal thing to do in Java is to test that the incoming argument values are valid, and if they're not, throw an exception. Right? So, exceptions. So this is where we go into some detail into what exactly exceptions are. Right? So you've seen exceptions in the course already. You've used them on assignment 1, probably assignment 2. Exactly what the heck are these things? So exceptions, that name is shorthand for exceptional event. Right? So it's something that occurs during the runtime of a program that is unusual. Right? And exceptions are objects that are used to indicate that something unusual has happened. Now the way this works in Java and the way it works in Python, it's similar in both languages, is that when a method or a constructor encounters an error of some kind, or something unusual has been detected, the method creates an object called an exception, right? And it hands it off to the runtime system. So when your exception object is created, the method or constructor immediately stops running, right? Whatever exception object was created now gets handed off to the to your runtime system. So this would be your Java virtual machine. The exception object contains information about what has occurred. Right? So it might contain information about what line number in your code the error has occurred on, It'll have the name of the exception, so illegal argument exception, for example, and it may include some other information as well. Right. So this act of creating an exception and handing it off to the runtime system is called throwing an exception in Java. In Python, it's raising an error. Right. It's the exact same thing, though. So to throw an exception, you already know this. You pick one of your exception types, you make an object of that type, and you throw the exception. So throw new illegal argument exception, or throw new null pointer exception, or something like that. Right. So the throws keyword actually causes the exception to be thrown. Right. And when you throw an exception, method stops running. Right. So any code in the method after the throw statement does not run. Right. If you're testing for inputs to your method, this means that you should probably test the inputs first before you do anything else in the method. Right. So a common mistake that newer programmers will make is that they will write the code for their method or their constructor, and then they'll realize at the end of the method or constructor that they should have been checking for the inputs. They should have been testing the inputs to make sure that they are valid. Right? And so the exceptions will happen at the end of the method or constructor. Right? You want to test for the whether or not your inputs are valid before you do anything, rather than do everything first and then test whether or not they're valid. Yeah?
What happens if you throw an exception that doesn't have anything to do with the program? Like if you're checking if something is an int and it's not int, you throw an index out of bounds exception, what would happen?
So I just have to make sure you, so I just want to make sure that I understood your question correctly. Yeah?
Index out of bounds exception and you weren't looking at the raise or anything. What did you do anything?
Oh, no. So you can throw whatever exception you want whenever you want. It doesn't matter where in your code, right? You can just throw an exception if you want to. And the language will happily throw the exception at that point in time. Yeah. Oh, no, here. So in left, so I'm going to return 0 here. And in right, I'm also going to return 0. Right? If, oh wait, I'm going to put in a void method here. Void some method. Throw new, whoops, sorry. Array index out of bounds. Sorry. Oh wait, what did I do? Oh, I deleted some code. Never mind. Void, sorry. Some method. Okay, there we go. Throw. Okay, you can throw an exception wherever you want, and the exception doesn't have to have anything to do with the method that you're in. Right? There's no testing for that sort of thing. Okay. There was something else you asked about that. Oh, I don't remember. Okay. Sorry, there was something that you asked about that's bugging me.
Like what if you were checking for an int?
Oh, yes. Right. Okay, that's what I wanted to talk about. Int x. Okay, so in Java, so it's a very common to see this, especially on a test. You never see it in code that's submitted because Eclipse or the compiler won't let you do anything like this. So on a test, it's often common to see something like the following: if x is not an int, throw new, like that, right? This is not sensible in Java, right? So in Java, x is an int, right? There's no way to call this method without passing in an int, right? So it's never sensible to test, is x actually an int, right? So for primitive types, code like this doesn't make any sense, and there's no way in the language to express it, right? So you never want to do this for primitive types. For reference types, you might do something like this, but I will show you how to do something like this at a later point in the course. Right? but you're never testing, it's impossible to call this method without passing in an int here, right? The compiler won't allow it. Sorry, I just have to check the time. Okay. All right, so here we go. So if you want to do precondition testing in a method like divide, the place you should do it is at the beginning of the method, right? Or as close to the beginning of the method as you can, right? So if s is 0, throw an exception, right? If you put in a little string here, that string will become part of the exception message when the exception is thrown, right? So whoever receives this exception will know that division by 0 has occurred at some point. Okay, so that's preconditions, right? Preconditions are conditions that must be satisfied by the caller of the method. Postconditions are the conditions that must be satisfied by the implementer of the method, right? So a postcondition is what the method promises, or the postconditions of a method describe mathematically what the method promises to do. Right? So it's a condition, right? So something that's true or false, right? That tries to describe exactly, so that the method must ensure is true when the method finishes running, right? So immediately before the method returns, those postconditions must be true, right? So it's the responsibility of who is ever implementing the method to ensure that the postconditions are satisfied. Right? If one or more of your postconditions are not true, then that indicates that something went wrong with the implementation of the method, right? Your code is buggy for some reason. Right? So again, the postconditions are essentially a mathematical description of what the method promises it will do. Now, because it's a mathematical description, it's often very awkward to express these things as true conditions. Right? So you'll see an example of that in just a second. All right, so if you have a non-static method, then the postconditions can involve, right, the return value of the method. So if your method returns a value, it's going to promise something about the value that's returned. Right? If your method is not static and it involves an object, then that method might change the fields of the object, right? It might change the value of the fields or change the state, right? So it can involve the fields of an object, right? A method can also, if it receives an object as one of its arguments, it might change the state of that argument, right? So the objects passed in the method, they might also change, and so that also becomes part of your postcondition. So in Java, postconditions are normally described in the documentation of the method. So return values, you know that that's described by an @return tag, right? This other stuff is probably described in the text of the description of the documentation. So for example, our x method for point 2 returns the x coordinate of the point, right? And so that's part of your postcondition, right? It's one of the postconditions of this method, right? It promises to return the x coordinate of the point. There are some other postconditions of this method that aren't obvious, right? Now remember, these are conditions, so they are things that are true or false, right? To properly express this as a postcondition, you have to express this as something that's true or false, and it's not obvious how to do that, right? There's also a hidden postcondition in this particular method, and so actually writing this thing out as a mathematical expression is a little awkward. All right, so this is how you might express your postcondition if you were trying to be extremely strict about trying to write this out as a logical expression. So our original method simply returned this .x. I'm going to insert a bunch of other code. So I have old x and old y, they're both marked as final. Right? They are the x and y coordinate of the point before the method does anything else. Right? So they are the original x and y coordinates of the point when the method was called. Right? My result is also marked as being final, so I can't change it after this point. Right? That's simply the x coordinate of the point. Right? And the end of the method, I can return the result. So your postcondition is a condition or conditions that are true immediately before the method finishes running. So your postcondition is evaluated right here, which you can't do in Java, right? In Java, the method stops immediately after the return statement, right? But conceptually, you want to evaluate the postcondition here, right? If I have all of these variables, I can now write the postcondition, right? So my postcondition is that this x equals old x, and this y equals old y, and this x is equal to the result, right? So what is that saying? Right, in plain English, it's saying that the method does not modify the state of the point, right? The method doesn't change the x or y coordinate of the point, and whatever value is returned is the x coordinate of the point when the method was called, right? And so even for a method as simple as this, right, trying to express the postcondition mathematically turns out to be quite difficult. You can imagine that for a method, say you have a method that sorts a list, right? You can imagine that the postcondition for that particular method would be very complicated, and in fact it is, right? All right, do I still have, yeah, I still have a little bit of time. Okay, so for a mutator method changes the state of the object, right? And so your postcondition for a mutator method will involve the fields of the object. So the other x method in our class changes the x coordinate to new x, right? And returns a reference to this point. So the postcondition here is part of the postcondition is documented in the return statement, right? But just as in the previous example, the real postcondition for this method is actually surprisingly complicated, right? In plain English, right, the true postcondition for this method is that the y coordinate of the point is not changed, right? So changing the x coordinate does not change the y coordinate. Right. The x coordinate of the point is set to the original value of the argument passed to the method. Right. So in other words, the x coordinate of the point gets set to new x. Right. And the return value is a reference to the point that was used to call the method. Right. And so it's possible to write this all out if you insert some extra variables and so on and so forth. Right. But it's not commonly done in Java. You might wonder why I'm telling you all this. So if you end up in the software engineering stream, or if you take some of the software engineering courses, there will be a lot of discussion about preconditions and postconditions and these things called class invariants. And you may learn about languages that actually have the facilities to check these things for you. Right? So there are languages that are meant for safety critical applications, right, where preconditions can be tested for you. Postconditions will be tested for you, and these things called class invariants can be tested for you, right? You still have to conjure up, you still have to tell the language, though, what is the actual postcondition, right? Or what is the actual precondition, or what is the actual class invariant, right? In Java, there's no good way to do this, and the tools that you might consider using that do this sort of thing are not particularly good. So we don't do any of that in this course. Okay, so is there any way you can check the postcondition? So, I mean, if you wanted to, you could try to, right? So if you're really concerned about correctness in your program, right, you could try to formulate the postcondition for all of your methods, right? And then before your method returns, you could insert an if statement to check the postcondition, right? If the postcondition happens to be false, then you know something has gone wrong in your method. It's not commonly done in Java. And doing this sort of thing imposes a cost on whoever's using the method. Right? So whoever's using the method, they're always paying this cost of testing the postcondition. Right? But again, there are languages that do this testing for you. Right? So the safety critical languages have these sort of facilities built into them. All right, I guess I should stop there, and we'll talk about class invariants in the next lecture.